Today's lecture is a little bit longer, but it is the first lecture in this mini unit that we are going to call Scientific Notation and One-Step Conversions. And so one of the first things I would like you to do is I would like you to pause this video and watch the video clip above. It's about 9 minutes, but it gives you a little bit of perspective in terms of what the powers of 10 really mean in terms of the metric system. Once you're done with that, continue watching the video. Now, scientific notation is an easy way to write very large numbers and very small numbers. So for example, the distance to the sun from Earth is been measured to be 149,006. I lied. It's even bigger than that. 149,600,000,000 meters. And that's a big number to have to write over and over again, so scientists would write it as 1.496 times 10 to the 11 meters. Another way to look at it, or another piece of perspective, would be the radius of a hydrogen atom and if you recall, the radius is halfway across, so be that distance right there. And if I was to write this out, scientists would say that we've measured the radius of an atom to be something like this. That's an incredibly tiny number. So scientists would write it using scientific notation like this. It's a much easier number to write with. So, you are going to be asked in this class to convert from scientific notation to regular notation, and there's a couple of things that we need to keep in mind. Number one, we're going to move you're going to be moving the decimal place the same number of digits as the exponent, or the raised number. On the 10. And then the other thing you have to keep in mind is that the positive exponents move the decimal place to the right, and negative exponents move the decimal place to the left. So the example that we are going to work off of today is 1.45 times 10 to the 8th power. So what I'm going to do is I see that the exponent is positive, so that tells me that I'm going to move it to the right. What happened here? Okay, then I'm going to move it to the right. So I'm going to take my 1.45 and I'm going to move the exponent 8 spots to the right. 1, 2, 3, 4, 5, 6, 7, 8. The decimal rather. And then I'm going to fill that in with some zeros. And then I feel the need to clean that up a little bit so that it looks a little bit cleaner. So 145 and 0, 0, 0, 0, 0, 0, comma, comma, and then that gives me my value. It is the same value, just written a different way. Another example would be in example number 2, in which case I'm going to have 8.22 times 10 to the, in this case, negative 4. So that negative 4, my exponent, tells me that I have to move the decimal to the left. So I'm going to start with 8.22, move the decimal 1, 2, 3, 4 spots to the left, put some zeros in there, and because I like to make things look clean, I'm going to put a 0 in front there. So now I'm going to clean everything up. 0.000 822 will be my value here. So the other thing that you're going to be asked to do is convert regular notation to scientific notation. And to do that, you count the number of digits to the decimal, and then you use that as your exponent. And so some things to keep in mind is that if the given number is greater than 1, the exponent has to be positive. And if the given number is less than 1, the exponent has to be negative. So an example that we might have would be something like this, where we'd have something like 56,800,000. Throw a couple commas in there just for fun. And then we are going to identify our decimal, and we are going to count back so that we have a number that is equal to or is between 1 and 10. So 1, 2, 3, 4, 5, 6, 7. So now I have a number, 5.68. It's between 1 and 10, times 10, and the exponent this time is going to be 7. And the 7 has to be positive because the original number was greater than 1. So something to keep in mind is that when we're writing these numbers, m times 10 to the nth power, m has to be a value that is less than 10. It is between 1 and 10. And n should be a whole number. So just something. In example number 2, we are going to take 0.0000012, and I'm going to write that as scientific notation. So the first thing I'm going to do is move my decimal. 1, 2, 3, 4, 5, 6. So I'm going to rewrite this because I now have a number between 1 and 10. 1.2 times 10, and I moved it 6 spots, but it's got to be a negative 6 because it's a number less than 1. So what I want to do is pause the video and try these 3 here and then check back in with me. And if you did these and you came up with the correct answers, your correct answers would be something like 2.45 times 10 to the positive 5. You would have 3.5 times 10 to the negative 3. And you would have 9.25 times 10 to the negative 2. Great job. I'd like you to pause the video now, and I would like you to give the next 3 a shot. And if you did those correctly, you would have come up with something like 7, 5, 0, 0, 0, 0, 0, 0, 0, 0. Okay. And we'll throw some commas in there because that makes it look a little cleaner. For the next one, you would have had something like 0.00952. And for C, you would have had 0.0000075. If you did well with that, congratulations, and it's time to move on. Here is a table that when you take chemistry next year, you may be asked to memorize parts of this table. You don't need to know much of this table for the scope of physical science, but I'm just trying to show you that every time we go up, by adding a 0, we have a different unit. And every time we go down by adding a 0, we get a smaller number that we have a different unit. So we have things like giga and mega and kilo and hecto and deca, and things like deci and centi and milli and micro and nano. Well, the thing of it is that you don't need to know all of those things for this class. For this class, you need to know the following. You need to know that 1 kilo unit is equal to 1,000 units. You need to know that 1 unit is equal to 100 centi-units, and you need to know that 1 unit is equal to 1,000 milli-units. I kind of made the joke in class that 1 kilo Sussex is equal to 1,000 Sussex, 1 Sussex is equal to 100 centi Sussex, and 1 Sussex is equal to 1,000 milli-Sussex. Now, the other thing that you have to keep in mind is that any base value or unit can go into the red box that's written above. The main ones you will see are G, which is grams for mass, so we could have kilograms, M, which is meter for length, so we could have centimeters, and L, which is liter for volume, we could have milliliters. So these you should know and memorize. And as an example, or at least in an effort to sort of have you put some perspective on this, 1 milligram is roughly the mass or size of a grain of salt. 1 gram is roughly the mass or size of a large paperclip. And 1 kilogram is roughly the mass or size of a giant tub of Nutella, which is delicious, and you should spread on your Eggo waffles in the morning. Also, the relationship between centimeters and millimeters is that in 1 centimeter, there are 10 millimeters, but centi is bigger than milli. And centi and milli both fit inside of 1 meter, which is what that is actually a cutoff meter stick up there. So, when we talk about taking a number that is in 1 unit and we're going to put it into another unit, we use the process that we call unit conversions. And the way that we do this is we have like these templates, and the templates help us to keep track of our numbers. They also help us to keep track of our units. So the first thing we would do is we would take the given unit and put it over 1. We would take a conversion factor, which has our new unit in it, and our given unit, or our old unit in it, and set it up in such a way so that there would be the ability to cancel some things out. So to put this in a numerical perspective, we could have 2.37 kilometers over 1. And my conversion factor, what we just said before, was that 1 kilometer is equal to 1,000 meters. And so if I set this up, I can now identify that the units for kilometers cancel out, and I'm going to end up with meters. So 2.37 times 1,000 ends up being 2,370 meters. So there are some rules or steps, so things aside. Note that I had the new unit on top and the given or old unit on the bottom with this, so here they are. And it's a lot, I get it. So just take a second, copy it down, pause the video, and then come back and listen to what I have to say. So what's going to happen is we are going to determine our relationships we're going to determine our relationships that are needed in the problem based on the given information. You will take your given value and you will put that over 1, and then we need to set up our conversion factor. And I wrote conversion factor the way that it is so that if we go back to our last, in our steps, I wrote it that way so that we could remember how to set those up. So we're going to write the unit of our given value on the bottom of the conversion factor so that the units cancel out, the given units cancel out. We will fill in the rest of our relationship. We will cross out units that can cancel, then we'll multiply straight across the top and the bottom, and then eventually simplify. So an example of this would be, oh boy. Okay, so an example of this would be like problem number 1 in your homework, which is the last page in this packet, the last page and a half of this packet, in which case we have something like 180 minutes. So it's 100, oh, that's not what we wanted at all. That's just plain silly. So we have something like 180 minutes equal to blank number of hours. Okay, and so we're trying to figure that math out. And so the first thing we're going to do is we're going to set up our conversion factor. Again, I'm writing it this way for emphasis. and we have to show our work. So, the conversion factor that you were given in your problem is asking you the relationship between minutes and hours. And we know that in 1 hour there are 60 minutes. So that's our conversion factor. So now what I'm going to do is I'm going to take my given value, my 180 minutes, and I'm going to put it over 1, because that's what step number 2 said. Then what I'm going to do is I'm going to set up my conversion factor, and I'm going to write the conversion factor in such a way that my given units will cancel out. So I'm going to take the 60 minutes and I'm going to put it on the bottom. Then I'm going to fill in the rest of the relationship, in which case I have 1 hour on the top. So now I'm going to cross out my units that I can. So in this case, units for minutes cancel out. And then I'm going to multiply straight across the top and the bottom. So I'm going to be left with 180 hours, really, over 60 minutes. Well, 60, because minutes cancel out. So now if I plug this into my calculator, 180 divided by 60, I get a value of 3 hours. So that's the answer, and that's how I would go work through these problems. There's one other thing in the homework that you might have a question about, as long as I'm thinking about it, and it's on the front part where you're asked to write a number in scientific notation, and you were given a value that looks something like this. So you had something like 3.4 e negative 12. Well, that's computer program talk or programming language for scientific notation, which is 3.4 times 10 raised to the negative 12th power. So that's all that is. And so what I would like to challenge you to do is, when I ask you to write something like that in scientific notation, just change the e to times 10 and raise the value to an exponent, and you should be good. So your homework is to do worksheet number 1. It's a 3-sider, sorry, but it's not too bad. And I hope you have good luck with this, and we'll spend some time going through this tomorrow.